Okay, so in this video we're going to be doing a worked example looking at interpreting slope and intercept. Now remember, slope is B in our terminology and A is intercept. Okay, and the slope is indicating a change in a response variable as the explanatory variable increases by 1 unit. All right, so in the example here, it's looking at day of experiment is our explanatory, and Y is our response. Okay, so what that slope would indicate, so we're going to calculate this, but if there's 50 bacteria, it's like A plus 50 X, then every day you're an increase of 50 bacteria. That's what we mean by 1 unit, because our unit is 1 day. The Y-intercept indicates the value of the response variable when basically time is 0, so when explanatory variable equals 0. So that's where it cuts the y-axis. All right, now we've got our data here, and it says the equation describing the relationship between the two variables. Now I put that data in here. This is what I've got, and as we've done before, we're going to go Control I, we're going to go add data and stats, and we're going to go, remember it was day and bacteria. Okay, sorry about this, I've just realized I didn't properly put the number in here. That should be 1100. Oops. Okay, that's now reflected in our graph. That looks much better. It looked a bit weird for a moment then. And we're going to go menu, we're going to go analyze, regression, show linear, and here is our equation. So it's y equals 202.5. This is, I'm saying that so I can remember, y equals 202.5 plus 206.25 plus 206.25x. Now, if you wrote that in a SAC or an exam, you wouldn't get the full marks. Probably an exam, you'd probably lose the mark. In a SAC, you're probably not going to get the full marks. The reason why? Because it wants it in terms of the two variables. The two variables aren't y and x, the two variables are day of experiment and number of bacteria. So the way we write that, what's y? Number of bacteria, I'm shorthanding a little bit, equals 202.5 plus 206.25 times day of experiment. Okay, and that's how you'd have to write it. Okay, that would give you the full marks. So the rate at which a bacteria are growing, now the hint here is rate. Rate corresponds to gradient. And our gradient is this one here. All right, so each day, remember that, so what it's saying is for every day I'm going to get 206.25. So 206.25 bacteria per day. Probably, strictly speaking, you would actually get rid of the 0.25. You're gonna say it's 206. Okay, so you pretty much say there's 206 bacteria per day that are produced. Okay, the number of bacteria at the start of the experiment, that's where I'm looking at this value here. So the number of at the start, that's saying at time, let's write it, time equals 0. Okay, that's what that y-intercept is basically telling us. So at the start, I'm going to have 200 and, remember I got 202.5, I've got to round it, so basically 203 bacteria at the start. Okay, and that's how we start to need to start interpreting these slope and intercepts. Okay, thank you.